Hello class, and welcome to Module 2. In this module and ongoing throughout the rest of the semester, I'll be following a format like this to demonstrate code both in class as well as in my recordings. This is actually just a skin on top of a Jupyter Notebook file, and I'll just show you here. If I close out of this mode, you can see this is just a regular Jupyter Notebook. I am partial to Jupyter Notebooks, so you will see me using it regularly. You can also code in PyCharm, or if you have another IDE that you're comfortable with, you can utilize that, but I am familiar with both PyCharm as well as Jupyter Notebooks. I just used this skin on top of Jupyter Notebooks to make it easier to present in class. So, continuing on from that, as I said, this is Module 2, Basic Variables, Arithmetic, and Casting. The first topic, and these topics follow the topic folders within Blackboard, is about the interpreter. I don't really have anything to show here. I just suggest that you go into Blackboard and you step through the topics in that folder just to make sure you're comfortable with that information that's there. It's informative and helps you get a better understanding of how an interpreter works, and gives you a little bit of information on using Python's command line interpreter. We don't really use that much in the semester. It's kind of a limited format where you can just run code line by line. We will mostly be working within IDEs or integrated development environments, again, such as PyCharm or Jupyter Notebooks. In topic 2, we actually get in and do some actual coding here. So topic 2 is about data types and variables. So here is just a cell within my Jupyter Notebook, and you can see that I am just doing a little bit of what's called string math. In this first line here, I'm doing a print statement, and anytime you do a print statement, you just type print, and then in parentheses, what you want to print to the screen. What I want to print to the screen is the word hello, a comma, a space, and the word Python, and then an exclamation point. Now, I could have stuck the exclamation point on the end of Python. I was just separating it here just to show that to concatenate strings in Python, all you have to do is just add them together. So you put a plus sign in between each one, and if you want spaces, again, you just literally put the space in between quotes. Now, I could have done single quotes or apostrophes here instead of double quotes. It is up to you. There are times where within your string you want to actually utilize an apostrophe, and in that case you would need to use quotes, because you can't have an apostrophe within the string and then surround it by an apostrophe. That would confuse the IDE. So this should print out a group of strings here, and then the second item in this cell, when I run it, is actually just multiplying the string hello times 5. So the output there is going to be the word hello over and over again. So you can see here's my string hello Python all added together or concatenated, and here is the word hello over and over again. So those are two bits of string math that you can do. I can also include what are called escape characters when I'm trying to print strings or other items to my screen. And here I'm showing you again that same hello Python string, but this time I'm also including 3 \T's. And whenever you use a backslash, Python will read whatever that is, and instead of just printing it to the screen, it will do what you want based on that escape character. So a \T is actually a tab character. So instead of printing \T to the screen, it will do a tab on the screen for you. So I'm adding 3 tabs into my screen. \T is pretty common. \N is also pretty common, which is a new line character. So if I go ahead and run this, you can see I get a bunch of space in between because it tabbed 3 times. In this next cell, I am doing some variable assignments. So again, another very simple thing to do in Python is to create variables and assign them. So I am creating a variable called first word, and then I'm just using equal sign and saying I want it to be hello. So now once this runs, Python will assign the word hello, or the string hello, into the variable first word. I'm doing the same thing here with Python. So second word is being assigned Python, and then I'm going to utilize those variables to output a string. So I'm doing first word plus a space plus second word, and you can see here that I'm not using a print. One of the convenient things about a Jupyter Notebook cell is that if you don't actually have an output on the last line in the cell, Python or Jupyter assumes that you want to output it, so it will just do it automatically. So if I run this cell, you can see that it puts those two variables together along with the space and prints it to the screen. Again, I could have just done this to get the same result. Continuing on, here I am going to, instead of assigning a string, now I'm going to start assigning numbers into my variables. Now, one of the nice things that Python does for you is that it will automatically assume data types for you. Now, there are times when that can get you into trouble, but in most cases, it's a convenience. So if I put in something that looks like an integer, which an integer is a whole number between negative infinity and infinity, Python will automatically assume that it's an integer. If I were to assign, which I'll do later, like 5.5, it will automatically assume that that is a float because it has a decimal point in it. If I assign something that is a string because I put quotes around it, it will automatically assume that it's a string. There are other ones that we'll get into through the coming weeks, but those are common cases. So I have a variable called myInteger, and I am assigning it the integer -5, and then just printing it to the screen. And then in the second part of the cell here, I am going to use a very useful function called type. There are a ton of built-in functions into Python, and again, we will be going over them throughout the semester. But type is one of those ones where you say type, and then whatever is inside the parentheses is what you want to know the type of. So I am going to say, find out the type of my integer, and then assign it to another variable called variable type, and then print that variable type. So I'm going to run this, and you can see that the first part of the cell, my integer -5, output -5, and then on the second part where I found out the type of my integer, you can see that it is a class of int because Python automatically assumed it was an integer for me. In the next cell, as I had alluded to, I am creating a float variable. So I am assigning 1.75 to a variable called myFloat, and then I'm just going to print the type of my float. So that should output a float type. And then I want you to note here that just because there's nothing after the decimal place doesn't necessarily mean it's not a float. If I do this, my float2 equals 25 point, even though it looks like a whole number and could be an integer, I am specifically telling Python I want it to be a float, so it will interpret that as a float for me. And you can see both outputs result in class float. On to the next topic, we're going to do a bit of arithmetic operations. It's just a continuation of what we've been doing, except more functions than what we had before. So here's a series of just common arithmetic operations. So, and I'm going through each one and then just directly printing them to the screen. So I can print 4 plus 7. You can expect that that's going to result in 11. I can print 2 minus 2. Which is going to be 0. 3 times 9, obviously 27. And then we get into some of the less common ones. Exponentials are done just by using 2 asterisks. So this would be 2 to the 4th. And then division, obviously, is a backslash or forward slash. And so 11 divided by 4, and then these are some of the ones that you may not have seen before. This is called modulus. So 13 modulus 4 is going to just return the part that didn't divide out evenly. So in this case, if I had 12 modulus 4, or 12 divided by 4, it would have resulted in a 3 with no remainder. But I'm going to have a remainder here of 1 because it doesn't fit evenly. And then this next one here is called floor division. Both of these are floor division. What floor division does is it divides the number and then only keeps the whole part. It truncates the remainder. The only part that's a little bit odd, so 10 floor division 5 is going to result in 2, but -9 floor division 2 is actually going to result in 3, or -3 in this case. I'm sorry, -5 because it's a 2. So it always goes the farthest negative, or the most towards negative infinity. So if this were to divide evenly, it would be -4. But in this case, because there's remainder, it goes to -5. And then you can do mixed type math in Python, and it will again interpret for you what you want the result to be. So if I first multiply an integer and a float, I've got these two numbers I'm assigning to variables. I got first number is 12, which will be an integer, and second number is 17.22, which is a float. I'm going to multiply them together. Now in regular math, you know this is going to result in a float because you're going to have decimal points. So if I take first number times second number and then print it, you're going to see that it results in a float because Python can see that I've got numbers after the decimal place. So I've been saying how great it is that Python automatically assigns types for you. You can override that so that you can be assured that you're getting a specific type. There are times when we have to do this, and we'll get into some of those later, but perhaps you want to have a string that is a series of numbers. Well, Python would automatically assume that that is a number or an integer, but maybe you want it to be a string of characters instead. You can override that by specifically saying what type you want it to be. So here's a couple of examples. I've got two numbers again that I'm assigning to variables, 1.5 and 2.5. Python's going to automatically make those floats, and then I'm going to add them together. And I can print the solution here, and it's going to be whatever those two are multiplied together, and then I'm going to print the type, and then I'm going to specifically override the type and then reassign it to the variable. So I'm going to say, instead of that float, I want it to be an integer. I'll just print this so you can see. You can see the two numbers multiplied together become 4. They become a float by default because I'm multiplying two floats together. But I'm going to override it as an integer here. And then I'm going to print the type to prove that it is now an integer, and you can see that here. And then I am going to just show you, if you print, or if you assign integer to a float, you can see that it just is going to truncate everything after the decimal place. So 4.86545, if I turn it into an integer, is just going to become 4. Python also commonly uses shorthand operators, especially for things that you are doing repeatedly. We're going to see a lot of this in like looping as we get into that stuff later in the semester. It results in the same thing, but sometimes people get a little bit confused by it because it just doesn't look like normal math. So here is an example. I've got these two variables again, total and other total. They're both assigned to 4. I'm going to take total, and I'm going to take total plus 1 and assign it to total. So in this case, since total is 4, this would become 4 plus 1, and then I'm going to assign it to total, and now total is going to output the number 5. And I'm going to print it here, and this is just a good example here of print where you're doing multiple things. Here I'm printing the string longhand, and then after that I'm printing the output of the variable total. So I'll get two things in my print statement there. And then the second part of the cell here, I'm doing the exact same thing, except I'm doing a shorthand version of it. So in the shorthand version, you can see this is other total. So again, that's 4. But what this results in is other total equals other total plus 1. Just like up here, it's just a shorter version. So this plus equal sign is just a shorthand version of saying variable equals variable plus 1 in this case. And then I'm going to print that output, and you'll see that they're both the same. So it's just, I just want you to know that while this looks a little strange, this and this are equivalent. And there's several of these, and you can look in the Blackboard shell to see the list. You can do it for multiplication and division, and etc. There's several shorthands available. This one is very common. On to the next topic, and if any of you have taken another programming language before, this is a little unusual because with Python, functions are so easy to use. You can introduce them very quickly, and then we'll be doing a ton with them throughout the semester, but it's nice to at least get familiarity with them early in the semester. So this is going to be an intro, and if it doesn't all completely jive for you yet, it certainly will as the weeks go on, but I want you to have awareness of it now as we get going with the semester. So as I said, many programming languages are introduced much later, but Python makes them very easy to use. And if you don't know what a function is a section of code that can be called to run from the main program or another function. You can pass it nothing, or you can pass it one to many variables that are used within the function, and then the function can return a result, or it can perform operations of its own. So it's just, and you can call these functions multiple times. I'll be doing that here in a few slides from here. But it's functions can help keep your code clean. It can help keep you from being repetitive, which is really important in programming. You don't want to keep repeating. Like if you have a piece of code that you have to keep running over and over again, you should be using a function. You shouldn't be writing that same code repeatedly. So here's a very simple example of a function, and this is the structure that you use when you create a function. It's always DEF, which means you're defining the function, you're giving the function a name, and then you have an open close parenthesis, and whatever's inside the parentheses is what the function is expecting to be passed for the function to run. Because there's nothing in the parentheses, this function is expecting nothing to be passed along with it when it's run. And this function, and then you put a colon at the end. And this function literally just prints a string of text. And it's just my number is whatever here. So this function does very little, but it's just a simple example. And there's a couple of things I want to note here. First of all, I'm going to run this cell, and you're going to see nothing happen. And the reason nothing happens is because I'm only defining the function. The function will not actually run until I call the function, which I'll do here shortly. But I'm going to run this function, and you can see once a cell runs in Jupyter Notebooks, it puts a number here. But you can see that nothing happened, but the function has been defined. The other thing, well, I'll show that here in a little bit. So here in this next cell, now I am ready to call that function because I know the function exists and I can utilize it. So if I'm going to call a function, all I have to do is just use the name of the function and then in parentheses whatever variables or numbers I am passing into that function. And again, this example, nothing's getting passed into the function, so I don't have to put anything in parentheses. Now once I run this cell, you're going to see that it outputs that string of text because it is saying I want to run the call me function, which goes up here and goes into the call me function, which exists and does whatever that function is supposed to do. In this case, it's just to print that string of text. So here's another function that's a little more useful. And it uses that shorthand notation that I mentioned earlier. So I'm creating a function called getBigger. So again, defining the function. Here's the name of the function, and here's the variable that the function is expecting to be passed within the parentheses. Now I want to note this. The variable is called x. X is the variable that is used within the function. When I pass a variable into the function, I don't have to use the same variable name. In fact, in a lot of cases, you don't want to because it can create confusion. But what is here is what is used within the function itself. So this function takes a variable called x and then adds 1 to it and then returns it. So x, again, this is that shorthand, x equals x plus 1. So if I passed 5 into this function, it's going to take 5, add 1 to it, and then return 6. So I'm going to run this cell to get that function to be defined, and then I'm going to utilize that function. Now, this is a while loop. We're going to get to while loops in a few weeks, so don't worry about it if this doesn't all make sense, but it's another thing that's nice to just see. So a while loop just keeps looping until you reach a specific thing, and then it quits looping. In this case, it's saying until y gets to 10. So I'm just going to step through this. So first I'm assigning y to 0, which means the while loop will continue to run because y is less than 10. And then y is going to get assigned the output from this function. So I'm going to call getBigger with y, which in this case is 0. And then it's going to go up here to my function, and it's going to run it. In this case, y is what I'm sending, but that is x within the local scope, which is 0. So now it's going to say, okay, 0, add 1 to it, and then return 1. So now y is going to get assigned the number 1, and then I'll print it. And now I'm at the end of my loop. And then I'm going to start the loop again. Well, y is still less than 10. And then it's going to do it all over again. This time I'm going to call the function with the number 1. The function's going to run 1 plus 1 equals 2, and then it's going to return 2. And then it's going to get to the end of the loop again, and then it's going to run again. It's going to do this again and again and again until y gets to 10. And at that point, the loop is going to exit, and then it's going to print whatever, because I just wanted to show the after loop code. And this is where I want to make sure that I point out Python is a tabbing structured language. So this while loop has a series of instructions underneath it. How it knows what instructions to run is based on tabbing. So everything tabbed underneath this, which in this case is y, or is this function call, and this print statement will be run for each while loop. Once the tabbing has ended, right here, it knows that that's no longer part of the loop. So it won't print whatever 10 times. It'll only print it at the end once the while loop is complete. This works with everything. So here the function, everything tabbed underneath it is part of that function. If it's not tabbed, that means it's not going to be part of that function. I want to really make sure you pay attention to that, because what I often run into with people is they don't get their tabbing right, and it causes them confusion. Or like, for instance, if this is like 1, 2, 3 spaces instead of 4, this isn't going to work because it's not tabbed properly. It's off by a space. People run into issues with that all the time. So just make sure that your tabbing is aligned. All right, so I'm going to run this now, and you can see that it runs through the loop 10 times and then prints whatever. So that's calling a function repeatedly. That's a lot better than me having to write 10 lines of code here for each number, right? That's the point of functions, is to shorten up our code and make it more simplistic. That's the last example I want to show from Jupyter Notebooks today. I just want you to know that throughout the semester, I will always be giving you these examples that I've run through in a format that you can utilize. They're available in Blackboard under the module Help Discussion Board. So each week, recall, there is a module help discussion board. I will post that week's examples there as a discussion board posting. I will be posting them as Jupyter Notebooks, and I will also be posting them in .py format so you can load them in a different IDE. Please note that you can load the .py file in PyCharm, but you can't just directly run it because it just ends up being a large like a single cell of programming, and it just doesn't run that way. So you would have to cut and paste out the parts that you actually want to run within PyCharm. If you do utilize Jupyter Notebooks, you can directly load it and run each cell individually. I also have all of my examples posted on my GitHub repo. You can see the link there. Just note that future weeks, prior to the week, I always update those examples. So if you download the entire semester now, I can guarantee you there are going to be fairly significant changes between now and the week that we are utilizing that set of examples. So just be aware of that. But you can download them at any time, including after the semester's over. I always keep that out there for students to utilize.